This presentation is on women and STEM. What factors play a role in the underrepresentation of women and girls in the field of STEM? The presentation will have numbers do not lie. It's pretty much facts that have just uh, in regards to the underrepresentation. Girls and women in the following high school, college, and workforce will talk about statistics as to why, or actual statistics as to what's going on when it comes to this underrepresentation, and the research findings from the American Association of University Women will talk about the different factors that lead to this underrepresentation, such as the social and environmental factors, college and university as a whole, and in influential biases. The next slides would be what can we do to change our world, and what are some of the recommendations coming out of all different studies that were actually reviewed. And the next thing would be references. Now, numbers don't lie. On average, 12th grade girls earn higher GPAs in math and science than 12th grade boys. This is according to the US Department of Education. Now, that actually changes as they move on to college and then also the workforce, making up only 24% of the STEM jobs in the US. This is in comparison the to actually women making up 48% of all other jobs. In 2008, less than 7% of the mechanical engineers employed were actually women. In high school, there are actually no visible gender gaps when it comes to this is definitely accurate for right here at this graph. You can definitely, it shows that the average number of high school credits earned in math and science combined by gender between 1990 and 2005. And you can see that over time, all students, both boys and girls, are taking more math and science credits, with both lines going up, and girls now earn more credits actually in math and science than boys do. Now, in high school, girls actually appear to favor biology, chemistry, and pre-calculus in comparison to physics. And you can definitely actually see that here. And then although girls are also slightly less likely to take calculus and engineering courses in high school, but the gender difference with boys, it's most likely statistically insignificant, being that it's such small numbers. Now, this graph shows students' average GPA in high school math and science combined over time by gender. High school girls now earn a higher GPA in math and science on average than their male peers. And it's also important to note that actually both boys and girls have over time have actually have improved their GPAs. From high school to college changes the dynamics drastically for girls, and it creates a gender gap of almost 50% in. So women are 50% less likely to declare a STEM major in their first year of college. So we actually have to, looking in 2006, only 15% of the first year female college students compared with the more than a quarter of the male college students plan to declare um, a major in physical sciences and in actually any of the STEM areas. if you actually did not consider the biological, agriculture, sciences indicated in blue in this table, you'll actually see that for STEM, only 5% of first year female students intend to major in any STEM area in college. Now, the way that this breaks down, if you look at in 2006, only 0.4 of female first year students plan to major in computer science compared to 3% in males. Also, only 3% of female first year students plan to major in engineering compared um, to the male peers at 15%. So that's 1/5. So this gap continues after college graduation, with women making up only the 24% of STEM workers in the US. And as you can see in the table here, they're definitely underrepresented in just about every area of STEM with the exception of biological scientists. The American Association of University Women reviewed many research projects with oh, looking at gender gaps in STEM and discovered 8 research findings that pinpoint exactly what is going on and what are the reasons for the underrepresentation of girls and women in STEM. 8 research findings were actually organized in 3 different areas. So, how social and environmental factors shape girls' achievements and interests in math and science, the climate of college and university science and engineering departments, and the continuing influence of bias. Reviewed, the following 4 items were actually contributing or are known to be contributing to how social and environmental factors shape girls' achievement in math and science. One of the first things is negative stereotypes about girls and women's abilities in math and science, growth mindset versus a fixed mindset, self-assessment and masculine fields, and spatial skills. One of these 4 areas. So, negative stereotypes about girls and women's abilities in math and science adversely affect their performance in actually these fields. There was some research done by Dr. Joshua Aronson, a psychologist at New York University, showing that negative stereotypes about girls and women's abilities in math and science persist and can adversely affect their performance in the field um, through a phenomenon called stereotype threat. And the way that stereotype threat arises in situations where a person fears that her or his performance will be evaluated based on a negative stereotype. The experiment actually uh, gave a math test to 2 groups of female and male college students with similar math abilities. One group was told that men performed better than women do on this particular test, and that was the stereotype threat group. And the other group was told that there was no gender difference, which is the no stereotype threat group. And looking at the results on the graph here, the researchers found that women did significantly worse than men did in the stereotype threat group. Women scored 5 on average and men scored 25 on average. But in the no stereotype group, women and men performed equally well. So this is definitely these findings point out that the stereotype threat is largely situational, and when the threat is removed, girls' performance improved. So researchers recommended that some simple suggestions that would have shown to lessen the impact of stereotype threat and improve girls' performance, such as exposing girls to successful role models in math and science to combat negative stereotypes among women and in the field. Explicitly talking to students about stereotype threats, which would actually then result to um, improved performance. Growth versus fixed mindset in math and science. Research done by Dr. Carol Dweck, a psychologist at Stanford University, showed that girls benefit from having a growth mindset, which leads to improved outcomes. And the way that if you just look at the table here, it actually lists everything in regards to a fixed mindset. So individuals with a fixed mindset would believe that intelligence is static. Because of this, they want to always look smart and therefore tend to avoid challenges, give up easily when they encounter an obstacle, see effort as fruitless, ignore feedback. Versus if you look at individuals with a growth mindset, they believe that intelligence can be developed. Because of this, they want to learn more and therefore tend to embrace challenges, persist when they encounter obstacles, see effort as a path to mastery. So the research findings are important when it comes to women. These research findings are very important when it comes to women in STEM because encountering obstacles and challenging problems is the nature of scientific work. So when girls and women believe that they have a fixed amount of intelligence, they're more likely to lose confidence and disengage from science and engineering when they inevitably encounter difficulties in their coursework. Even though this is actually true for all students, but it's particularly relevant to girls in math and science, where negative stereotypes persist about their abilities. So in this slide, you'll actually see that there was an experiment done in the experiment that was done by Dr. Shelley Carell, where a group of students was actually in the group of students that they were actually asked, how high would you have to score to be convinced that you have a high ability for this particular task? So in a group of students where the students were told that men are better at this task, women indicated that they would have to earn at least 89, 88.9 or 89% to think that they had high abilities in the area. On the other hand, men thought that if they scored 79, that would indicate high ability. So that's a difference of almost 10 points. However, in the other group where students were told there was no gender difference in performance of this task, both men and women had a much more similar idea of what the score would indicate high ability. So they were actually both within not even 1% off. So if we think about these findings as it relates to math and science fields, in the fields in which men are considered to excel, it suggests that girls believe that they have to be better in math and science than boys believe they have to be in order to think of themselves as good in these fields. So there are many. So when choosing a career, it actually now becomes even more important that girls succeed and believe that they actually and do not do not do not self-assess themselves on their math abilities as lower than boys in order to then be to disregard that as a field. So one of the other things is spatial skills, and the American Association of University Women's research found that, or actually review found that spatial skills is one of the largest and most persistent gender gaps when it comes to these cognitive skills between boys and girls. Now, spatial skills are thought to be critically important for success in the fields such as engineering, and many people believe that they are innate. And therefore, some believe that this is why the gender difference, um, and it explains why there's so few women in engineering. But on the other side, Dr. Cheryl Sorby at Michigan Tech actually conducted some research and that actually showed that an individual's spatial skills can improve drastically in a short time with a simple training course. And she conducted this with some college students who failed a spatial visualization test and but then took a 10-week training course that meant just 4 hours a week, and their scores improved on average of 52 before the course and to actually 82 after taking the course. So um, we have, I mean, this is a 30% chance or 30% improvement in just 10 weeks. So having these good spatial skills can help to retain women in engineering and encourage girls towards science and math because we use spatial skills to interpret diagrams, drawings in math and science as early as elementary schools. So the second area that comes out of the research is the climate and culture in science and engineering departments in college and universities are especially important for women, both students. As we saw earlier, the huge gap in for freshman year students who major in STEM or who at least intend to major in STEM being a 50% gap almost. Um, now, the difference in most pronounced engineering and computer science, that actually is where the biggest gap is. But with some research conducted by Dr. Barbara Britton compared successful and more typical physics departments, um, the research actually showed that with some small changes in recruitment, admission, and curriculum, it can definitely help improve climate, which then will lead to attracting and keeping female students. One of the big recommendations was that they actually recommend Dr. Ritten and her colleagues actually recommend that departments actively recruit female students. Even though this is kind of obvious, but most departments don't actually recruit. They just normally just wait for students to come to them. And they do encourage that departments do offer introductory courses that emphasize in broadening applications of science and technology instead of focusing only in the technical aspects of the subject. So this chart shows the percentage of tenured and non-tenured faculty who are women in the selected STEM fields. Uh, First, we see that women make up a smaller share of the faculty in engineering and physical science and computer information sciences compared to the biological and life sciences. Second, we see that women make up a far smaller share of tenured faculty in all of these fields. This is significant because tenured positions are more secure, higher paying, higher status positions in higher education. The research that was conducted by Dr. Kathy Trower at Harvard University found that among tenured track STEM faculty, women were significantly less satisfied than men with the department climate. And they also, looking at it, they did not, they found that they did not actually feel like they fit or belong in the department compared to their male peers. Now, this is, of course, very important because if you don't feel like you actually fit or belong, then you're more likely to leave, and fitting in is also important for getting tenured. So, the third area that comes out of the review is bias, often unconscious, continues to limit women's progress in scientific and engineering. So, some research that was done by Dr. Banerjee and her colleagues at Harvard University shows that even individuals who consciously reject negative stereotypes about women in science often still believe that science is better suited to men than women at an unconscious level. These unconscious beliefs or implicit biases may be more powerful than explicitly held beliefs and values simply because we are not aware of them. So Dr. Banerjee co-developed the implicit association test, which is basically a test that measures how we associate different aspects to determine attitudes about different groups. And so one of the examples being the gender science implicit association test measures the degree in which people associate math and arts with male and female. Since the gender science implicit association test was established in 1998, more than 500,000 people from around the world have taken it, and more than 70% of test takers more readily associate male with science and female with arts than the reverse. Now, this implicit bias may influence the girls' likelihood of identifying with and participating in math and sciences, and contributes to the biases in science and engineering fields, in education and workplace, even amongst those who support gender equity. One of the things that we can actually do is having positive images of women in science in the office, the classrooms, at homes, in order to help reset these biases. And if you would like to take the test yourself and see, and also there is like quite a few other tests out there to see if you have any unconscious biases. I can guarantee you it is quite entertaining. I actually took a couple myself because they are anonymous, and so it was actually quite thoughtful. Women working in non-traditional fields like science and engineering are often find themselves in what is called a double bind. So there was some research done by Dr. Madeline Haleman at New York University that shows women in these so-called masculine jobs or non-traditional fields, which would include scientists and engineers, often find themselves in this what is referred to as double blind. And in this case, it's first women in these so-called male jobs are often judged to be less competent than their male peers unless the woman or the women are clearly successful at their job. But when a woman is clearly competent in a male job or position, she's often judged to be less likable. Because both likability and competence are needed for success in a workplace, women in STEM fields can find themselves in a double blind. So the implications of these findings are astronomical. Astronomical. Being seen as either less competent or less likable can affect everything from your relationship with your peers, your evaluations, your recommendations for promotions, and or salary increases. What do we do to better our world for girls? We can expose girls to successful female role models in math and science. Teach students, all students about stereotype threat. Teach students that intellectual skills can be acquired. Praise students for effort. Highlight the struggle. Gifted and talented programs should send the message that they value growth and learning, not just a fixed intelligence. Set clear performance standards. Help girls recognize their career relevant skills. Playing with building toys such as Lego or blocks, as well as drawing, can help students develop. So some of the things that universities can do is actively recruit female students, emphasize broad applications of science and engineering in introductory courses, review admissions policies to ensure that departments are not unintentionally weeding out potential successful students, such as requiring that they have previous exposure to engineering. Provide mentoring for junior faculty, so in order to make sure that even those that are non-tenured become tenured. Implement effective work-life balance policies to support faculty. Raise awareness about bias against women in STEM fields, and create clear criteria for success. Here are the references. Thank you.